Now, when n is an integer, we know the derivative of the function fx x to the n is differentiable. And we know that the function is differentiable and its derivative is nx raised to n minus 1. This we had proved in first calculus course, and you do this using properties of polynomial. And you can talk about properties of polynomial when n is positive. When n is negative, then you have rational functions and you can still prove this. But what happens when n is not an integer, neither positive nor negative whole number? So how do we find we know that this is the derivative. We have used it several times, but we had never proved it. So fix any real number n. Let fx be x to the power n. Then take natural log of both sides. Natural log of fx is natural log of x to the power n. That n jumps out. Now you take derivative of both sides. Derivative of the left equals derivative of the right. This gives me 1 over fx and chain rule f prime x equals n is a constant. Derivative of natural log x is 1 over x. So what is f prime x? Well, get the fx to the other side. F prime x is n fx over x. But what was fx? Fx was x to the power n. So one of the x's reduces and you have nx to the n minus 1. Notice here n could be any real number. Okay, and that's the amazing part of this proof. Now here is a complicated function. Find the derivative of this function. So we are assuming it's differentiable and so on and so forth. Well, this is again, we are going to use properties of natural log. Set y equals x to the power sine x. Apply natural logarithmic function to both sides. Natural log of y is natural log of all of this. The exponent comes out. Sine x times natural log of x. So that's a product rule right there. Take derivative of both sides. Derivative of this is 1 over y times derivative of y. Okay? Because we are taking derivative with respect to x, we need to use chain rule. Y is dependent on x. So 1 over y times y prime. Whereas this calls for product rule. That's a product. So derivative of sine, that's cosine. Natural log as it is plus sine as it is times derivative of natural log 1 by x. So simplifying this as a common denominator with a common denominator x. So x multiplies here, x cosine x natural log plus sine x all over x. That is y prime over y. So what is y prime? Multiply both sides by y. Y times your expression. Y itself is x to the power sine x. So you got your derivative. All right. Now, let's define number e as a limit. Let fx equals natural log x. Then we know that derivative is 1 by x. So when x is 1, derivative is 1. That is f prime 1 is 1. But what is f prime at 1? By definition, it is the limit x going to 0. Sorry. F of x plus 1 minus f of 1 over x. That's what derivative definition is by limit. This limit equals 1. But what is f at 1? Fx is natural log x. So when x is 1, natural log of 1 is 0. So I don't have that. That's 0. In other words, limit x approaching 0, f of x plus 1 over x is 1. What was fx? What was f? Natural log. So f of x plus 1 is natural log x plus 1 over x is 1. That's the limit. So this, mind you, you can think of it as 1 over x. In other words, it becomes a power. Natural log of x plus 1 power 1 over x, its limit as x approaching 0 is 1. Since the exponential function is a continuous function, we have, well, this limit is 1. I will take exponential of both sides, and because exponential is a continuous function, the limits continue to agree. Limit x approaching 0 e to the power natural log x plus 1 the whole over x 1 by x equals e to the power 1. Well, the whole point of taking exponential is they cancel each other. I'm left with x plus 1 power 1 over x. X plus 1 power 1 over x, limit x approaching 0. E to the power 1 is simply e. I have written this first just to tell you this is definition of e. E is defined, this is the number e as a limit. So this is the Euler number e. Limit x approaching 0, x plus 1 power 1 over x. Another way of seeing this is, well, you can think of a set n equals 1 over x. So n could be bunch of integers, any set of numbers, any sequence of numbers. You see, x approaching 0 is same as saying n approaching infinity. So this limit can be rewritten as follows. Limit n approaching infinity, x is 1 by n plus 1. 1 by x is n because n and 1 by x are reciprocals. So this is a standard way. I will exchange these two terms, and you have limit n approaching infinity 1 plus 1 by n power m. This limit is definition of e, or in limit form. Okay, both star equation and star equation are acceptable. All right, so next we are going to start on problems for web work. Until then,